applied science in cybersecurity and data privacy, now pursuing my bachelor's of cyber defense, also at Selburg College, and I'm one of the interns that helped work on this project. So.
Tanshi, bonjour. Indigenous Kaza Bruce, that is my name. I'm also from the Selburg College area, enrolled as a Vermont Heaven Advantage Chippewa. And this is our project. Right, well, we both primarily picked the project for the similar skills that we'd be developing, like machine learning, engineering programs, just a lot of tinkering and testing, trial and error, stuff that we would commonly use as cybersecurity professionals.
So I actually did almost all the nature and engineering camps with Austin and Jody throughout my middle school and high school years, and I did work with robots quite a bit. So I just thought this would be connected in a way, and I have never worked with drones. It was a completely different universe, but there was also a lot of similarities, and I also just wanted to see, connections to cybersecurity and how we could encrypt between the drone and everything else. Okay, so some of the hardware we did with the drone, we started off, we got the frame, we had to solder on the wires. Don't be fooled by these pictures. Isaiah and I soldering actually sucked really bad, but we learned, and that is a trend in this presentation. We learned a lot. So we basically just took the wire and the solder and put it together, and yeah. So we have to solder the wires on. Isaiah did the little battery connector, and it actually, we ended up screwing it up because the plastic melted. So we just had to do a whole new one. We built the frame with our flight controller and everything. We have our GPS up here as well. We'll talk about that a little later. And then we programmed it to do some pretty cool stuff, which we'll also talk about a little bit.
Alright, so here we can see a little bit of the power distribution board. It's basically what takes our massive battery that controls how much thrust we get, our flight time, and it makes it safer for each of the motors instead of just being raw battery and going crazy. As Aaliyah said, right here we have to pour solder into there and get the connection between the hot wire and then the ground to each of these, because they all need their own ground and power. But after we did this, we had to put on the flight controller afterwards and tinker after every step to program it, see, test it, and we'll get into a little bit of that in the next slide. Oh, okay. I can talk a little bit about this. So a lot of our testing was with this program called Mission Planner. It has a lot of functionality for while you're still flying in, setting the parameters for, let's say, how high it stops at, the order of the blades, propellers, GPS data, compasses, just all sorts of, you don't really use any other programs aside from this one. That's what's so cool about it. But there are other alternatives, some that are more simple and some that are more specialized. And here's some of the examples of the diagrams we're going to look at to follow while we're wiring. And we did put some on backwards multiple times, trying to do it over, then doing the same thing on accident 3 times. We have enough electronics inside of it so that it protects it even if you do cross paths or solder connections together. So we're pretty safe. It's just a lot of hiccups, and it does tell us whenever there's certain things wrong with it.
Okay, so with our drone, there were different setups that we had to configure it for. Our drone, it looked more like this one, but for some reason, it was not configured in this setup. it was configured in the H mode, and we flew it, and it still worked, it still ran, but it turned over, it flipped, it just did not want to do anything fun. So then, John was like, okay, everything is working. Is it possible that you guys literally just don't have it in the right mode? And we're like, no, that can't be it. And we looked, and it was literally the simplest fix ever. We just had to change the button. So then, once we got it into Quad X, it flew like perfectly.
Alright, whenever we got it flying and we had the order all ready, we decided to go to the next step and then put on the GPS here. And that was pretty easy. Well, we did torque it down a little bit too hard and it was like a little bent, but that didn't do anything wrong with it. But once we did that, we had to establish a connection. We were working in a basement, so we had to like go outside to do that. It just wouldn't collect from there. But we were able to tell that the compass works, so knowing which direction through magnetic fields. And we were able to calibrate it in a little video here. I don't think it's able to play, but we do have some for that. We picked up the drone, we'd orientate it, and then it'd give little happy beeps after like so much progress. So that's also a mission planner for you. Intuitive.
Okay, so we'll just explain what happened here. We put videos, and we didn't know if they were going to be able to be used, but that's okay. So in the first one, this is actually when it was configured in the Quad H configuration. And it basically just spun around on the ground, and one of our propellers, it got super damaged. But then that's kind of when we figured out like that's what was wrong. And in this one, this was a different test flight where we shot it up way too high, and it crashed basically. And the arms fell off, but everything else was fine. The wires were still together. It was just the frame that broke. Okay, so then our outcome, I'll just say this, in the end, we learned a lot. Our drone broke a lot. It was a very, very big learning experience, especially for me. Because as someone in cybersecurity, I never really work in the hardware part of it. And then also, John, he's like, I never really work in the cyber part of it. So it's like we were kind of putting our two things together. But we did, this is Isaiah flying the drone. You can kind of see it, but he looks like a little happy guy there flying the drone. And we did have our best test was, we had it in the 3 different modes, and I'll let Isaiah talk about it.
So on the drone controller itself, the way bottom left switch, it's almost like a video game controller, but instead of pushable buttons, it's little toggleable switches, up, down, or some of them have like up, down, middle. The bottom left one is usually the one to turn on the blades to arm it. And in 2 of the modes, that immediately sets up the blades. Whereas in the throw one, it sets it to like turn on, let's say its brain and think about it. And the moment the accelerometer, it knows that it's going at a certain speed and a certain height change, it kicks on those blades and it stabilizes and gets to a certain altitude that you set it at. Well, we didn't set that entirely yet, and it just kept going before it hit its limit or changed modes again. We just killed it to prevent any damages. And that's why it broke. But the other 2 were really successful. We were able to fly it up like there was no wind and no play in the wings. That was the stabilized, whereas the loiter, it kind of just stays at a specific altitude and it'll just hover there. You don't even have to touch the controller. And we have another video here of the drones that they work on to collect data for their research. They call it a fully hand grenade for reasons unknown. It also has a payload attached to it to give it more weight and to simulate like things that it's carrying or other fundamental activities they have. But essentially this one has a camera on it and it collects data, and some of them even have like IR cameras that can see in like heat, and then they'll give like 3D images, and they can take all of their data and build models in computers in a way that they call like computer vision that they're researching and studying. But overall, it's pretty fun, and we're learning the more you know about these drones, the more you can add into them, plug in little modules and tests and sensors, and really the possibilities are endless with it.
So one thing I did want to mention, so we did have to talk about why it was culturally significant. And one thing that drones are used for a lot is search and rescue missions. And I know, like, as Native Americans, we have a lot of MMIWP cases, and these drones could potentially be used to go for these rescue missions. So that's just, I thought about that last night, and I thought it really did inherit to our culture in a very special way. So I just wanted to mention that. Okay, so I just wanted to acknowledge a few people. Our professor, Dr. Jeremiah, for allowing John, he's here, if John wants to wave or stand or something. He was great, he was our teacher, he was amazing. And all of the nature and EPSCoR staff and everyone that was involved in this program, all of like the different facilities we used at UND, we did use the Tech Accelerator a lot, and the RISE office. That is where we flew everything. And we also learned from a lot of the other interns that were there. They were also working on the same drones as us. And all of our student mentors, we have a few here, they were very special, and I know that we made a lot of lifelong connections with them. And for the amazing College of Engineering Minds for allowing us to go out and do fun stuff. So, and then just one more quick note about John. He was great. He allowed us to make mistakes. He didn't want to just show us what to do. He wanted us to leave and to be able to go home and know what to do. So he would give us like a little hint as to what we were supposed to do. And then if we didn't figure it out, he would come in there and he would show us exactly what to do, which is an amazing teaching style. All right, and that's all. Thank you guys very much.
All right, questions? Jim?
Out of curiosity, are either of you considering getting your own pilot's license?
Maybe a drone pilot license.
Yes, should be worth it.
So as you were kind of studying and both interested in cybersecurity, did you start to see opportunities where drones and cybersecurity have some interplay?
Well, we did have an idea to add on a type of router, repeater sort of deal, like more antennas and radios.
Okay.
And there's one project that we saw another group doing very briefly. They have a like sort of relay station for communications. They had like way fancier drone that was like probably closer to the $70,000, $100,000 range. And that could just be the drone itself and not the electronics. But we had a very small version of one that we're thinking about adding on to a Raspberry Pi. Something that we kind of work with a little bit more as cybersecurity professionals. But the more we add on, the more we learn, the more we have to test, and we're very, very short timed.
Right.
We could have worked on this for 8 weeks, 10 weeks, and still had just as much fun and stuff to show for it.
Yeah, very, very interesting project. In one slide, you mentioned that you plan applying for funding to set up a drone working club.
Oh yeah.
What's your plan? Where do you plan to apply for funding?
There's this one program, I think it's called like Space Grant through NASA. That's one avenue. If you can prove that you have like a competition team, they're willing to give out like seed money for that. Otherwise, just setting up a club and getting enough students interested in it. With our college, we can fundraise on our own and get things going from there. I do know that our high school has a robotics team, so as they graduate and go into the community college, they'd be more apt to that sort of stuff.
Yeah, that's nice. You like?
Yeah. Oh, and also our AHEC has competitions for drone missions. And then they also have that sponsored, I think, by NASA in part.
Alright, so I have one, right? So you already said it was fun, and it looks like it's fun. How much crashing happened here?
How much crashing didn't happen?
So there was more non-crashing than crashing, huh?
Yeah.
Okay.
Because like flying sideways, there's times where we figured it would be okay. Like 3 blades would be going right, 1 propeller was upside down, and it was really hard to tell. And it'd get enough thrust, but as you'd like give it more directions to go into, it kind of struggle, or maybe the GPS wasn't calibrated right, so like whenever it tried to be stable, it kind of like wobble in the air. But once we got everything working out, it was just super smooth, like a balloon floating in a windless room.
Those times were great.
Yeah.
That's awesome. Yeah, it sounds great.
Yeah, once we got to that part, we ended up crashing it anyway. We went out with a bang.
That's the only way to do it, right?
There was a cliffhanger at like almost every end of the day. Like we did something new and exciting
We
to
were
like
so
come back to.
excited that we succeeded at something, and then at the end of the day, something new would happen. But that's okay. We learned a lot.
That sounds perfect. That sounds very science right there.
Yeah.
All right. Well, thank you very much.